Hello, this is Mr. Holly. We're going to be looking at Module 2, Lesson 17. And in this lesson, we are going to begin to model some real-world contextual problems using algebra. We are also going to be looking at how to solve them using arithmetic, tape diagrams, and really any method that you think would be appropriate. The goal here is to give you several different ways to go about solving these real-world problems, and also to help you to draw some connection between different representations. As we begin to work with equations, it's going to be important that we can draw connections to what are the meaning of the variables and pieces of equations and things of that nature. So let's take a look here at the problem. The problem says, Zach and 3 friends went to a movie. The first thing I'm going to identify here is that there are 4 people. I think that's important, so I'm going to underline it. I'm going to make a comment there. They each got a ticket for $8 and the same snack. So $8 each and a snack. I don't know how much that snack was, but they got a snack. If Zach's mom paid $48, that would be the total, $48 for the tickets and snacks, how much was each snack? Another thing I want to notice here is the question that it asks is how much was each snack? When we're doing these contextual problems, these real world problems, it's important to identify what the question actually is, because the question usually will tell us what we're trying to solve for. So if we end up using an algebraic model, the question oftentimes is going to tell us what the variable represents. What do I not know in this problem? I don't know the cost of a snack. So if I was going to create an equation here, my variable, which we'll call S, is probably going to represent the cost of a snack. Okay? So essentially what I'd like to do now is look at this 3 different ways. I want to look at this from an arithmetic perspective, like we're going to use an arithmetic strategy. Then we're going to use a diagram. Then we're going to use an algebraic equation. So we're going to solve it 3 separate ways, okay? The first way would be to use arithmetic. And what I'd like to do is think about this as if they go to the movies and there are 4 people and it's $8 a ticket, then I would think about this like 4 times 8 is 32. So that's the cost of the tickets. And I know that the total cost was 48, so if I subtract the cost of the tickets, I get 16, and that's the cost of the snacks. And there were 4 people, so I could do 16 divided by 4, and that's $4 per snack. And that's the right answer, and that works. Good thinking. But what if I wanted to draw this as a diagram? Well, I could put, in this case, we're talking about a total of $48 being spent. So I'm going to draw a box that's worth 48. In that box, we had tickets and we had snacks. So here I have my 4 tickets. My 4 tickets were $8 a piece. So I could draw it like this. That's $8 a piece, which makes this part worth $32. And over here I had 4 snacks. I could draw it as 4, I could write it as 4S, or I could put 4 boxes. Let's actually do that. Let's go ahead and say I have 4 snacks. So that's snack, 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 4 snacks. Okay, these 4 snacks, if the total was 48, the tickets were 32, 48 minus 32. The 4 snacks must be worth $16, okay? And if 4 snacks are worth $16, what would be the cost of just this one snack? Well, 16 divided by 4, each snack must have a cost of $4. So our answer is right here, $4, based on our diagram. Now, algebraically, how could we do this? Well, what I'm thinking here is this is 4 people times $8 plus 4 people times the number of snacks. It could also be written, I'm gonna write it up here, 4 times 8 plus S. But basically, I'm distributing that down here. I've got 4 times the number of tickets plus 4 times the number of snacks. $32 plus 4S. We know that this is equal to 48. Sorry, this should be an equation. Let's put our total over here. So now if it's equal to $48, I've got $32 for the tickets, 4 snacks, whatever the cost of that snack is equal to the $48. That's how much Mom spent. I'm going to subtract the cost of the tickets. And we'll see that my 4 snacks are equal to, if she spent a total of $48, 32 of it was on tickets. That means the other 16 was for the 4 snacks. Now I can take these 4 snacks, I can take this $16, I can divide by 4 and find that each snack costs $4. So it's $4 per snack. So here I've got, using arithmetic, using a diagram, or by creating an algebraic equation and solving that equation, I can see that the cost of a snack is $4. Now, not only can we do it 3 separate ways, arithmetic, diagram, and algebra, but there's another way of thinking about this problem. I'm going to erase this work, and we're going to do it all over again with a completely different thought process. In that process, basically what I was doing was multiplying 4 times the number of tickets and 4 times the number of snacks and trying to find my total cost of tickets, my total cost of the snacks, and then figure out how much each snack cost. Let's change the thought process. Here I have a total cost of $48. I could have a new strategy. My new strategy could be, hey, I just want to know how much one person cost. Because if you tell me how much one person cost, I can tell you how much their snack was, right? So $48 divided by 4 people means each person costs $12. If each person costs $12, I could subtract the cost of their movie ticket and get $4, and that would be the amount of money that was actually spent on the snack. $4 per snack. Right, and we'll run through this again. Here's your total. That's your number of people. So if I divide the total by the number of people, it's $12. That's the cost per person. Now my cost per person minus my ticket. This is my ticket. The cost of the ticket. And now I've got $4 left, and that's what the snack cost. What would that look like as a diagram? Well, let's draw it again. Is our total still 48? Yeah, it's still $48. Total's still $48. But now instead of looking at it as the total price of the tickets and the total price of the snacks, I'm going to look at it as how much did each person cost. So each person was 8 plus S, or $8 plus the cost of a snack. And if I think about it, that means that each of these boxes would each have to be worth $12, right? Because the total was 48. So each of these individuals, Zach and his 3 friends, cost $12. So I'm going to label just this box as $12. So if this box, this person, this one individual is $12, his ticket was $8, plus he had a snack, well, I could think of that box as $8 for the ticket plus $4 for the snack, right? And that means that's $12 that was spent on this one individual. Algebraically, what would that look like? Well, 4 people, each of them cost $8 plus the price of a snack, is equal to $48. Well, I could distribute. That was kind of our strategy the last time. 4 times 8, that tells me the amount of money that I spend on tickets. I don't want to do that. I don't want to know the total cost of tickets. I want to know the cost of one person. So I'm going to take my total and I'm going to divide it by 4 because there were 4 people. Now I get 8 plus S as my cost for one person. That's $8 ticket plus the snack. And I get $12 as my cost for one person because it was $48 for all 4. We divide that by 4 and we get 12 as my cost for one person. Now, if I subtract the cost of the ticket, I'm left with the cost of the snack is $4. So here what you've got, multiple ways to solve these real world problems. We can think about it with distribution. We can think about it in what we would call factored form. The cost per one person or per one individual in this case. We can use arithmetic. We can use diagrams. We can use algebraic equations. And the goal here is that throughout 7th grade, you're going to grow in your ability to do all of these practices and eventually get very comfortable with making algebraic equations that will help you to solve these problems. So, thank you.